I'm Melissa.
And I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life.
Of your everyday candles.
Oh,
well,
really?
That's what we're going to be talking about today. The long awaited, since our experiment aired on Monday.
Nice. Very cool.
So we're going to be talking about, one, how candles work.
Okay.
Two, how that magical smoke trick works.
Right.
So have you thought at all about that magical smoke trick since we
Just
did it?
a little bit, but I don't know if I have any strong theories. But I actually maybe should I try to throw it out there or just let you tell me?
Yeah, try to throw one out there.
Okay. So I know we've talked about fire before, and that's still a mystery to me in a lot of ways, even though we talked about it.
Yeah.
I think our episode was like, what is fire? And I'm still kind of not always sure. But one thought I had was just the fact that we talked a lot about energy being a part of that. And also smoke maybe still has some energy to it or something like that. Because it's not like it would all just be gone, or even think about heat, Yeah. It's like it would all be gone immediately when the fire's blown out. So my thought was maybe there's something to the fact that this smoke still has some of the makings of fire in it, regardless of how unscientifically someone like me might try to put that might allow it to catch fire more easily than obviously our air doesn't just catch on fire. In
the last thing you said, I think, is the key. There's something still in the smoke that has the makings of fire in it.
Nice.
Okay, so let's talk about that. And
Okay.
Here's how it started also. I guess before we talk about that, a long time ago, Jam just texted me out of nowhere, no context, what is wax?
Oh, yeah. Yeah, I did do that, didn't I?
And so I was going to do an episode on that, but what wax is pretty boring.
Man.
So wax is a long chain of carbon and hydrogen.
Mm-hmm.
It usually has a functional group on one side. And because it's long chains of carbon and hydrogen, we talked about this before, the shape of a carbon bonded to four things is what's called a tetrahedral.
Mm-hmm.
It's kind of a weird shape. You can Google it, look it up, or maybe I can show you on a modeling kit.
Okay.
And when you have long chains of carbon bonded together in a tetrahedral form, they kind of make a chevron. The carbons bonded to each other make a chevron pattern, that up, down, up, down, up, down.
Got it.
And if you have a lot of long chains of that, they can stack into each other really nicely.
Oh, yeah. We've talked about something else that does that.
Yes.
I can't remember what now, but.
Margarine.
Oh, yeah. That's right.
That's why we hydrogenate oils, to make it carbon bonded to four things, give it that chevron pattern.
Right.
So if you're trying to imagine at a molecular level what wax is, it might have a functional group on one side. We've talked a lot about functional groups. It's just arrangement of atoms.
Mm-hmm.
But the main part that makes it up is a long chain of carbons and hydrogens. So visualize in your mind carbon bonded to a carbon, and like one carbon is down, the next carbon is up. One carbon is down, the next carbon is up, to make a chevron pattern of carbons bonded to each other.
Got it.
And I can also post a video of that on Instagram. So because they fit nicely into each other, they stack well, they're going to have solid intermolecular forces, so they'll be able to be solids at room temperature.
Got it.
That's basically what all waxes are.
Okay.
And there's just variations of functional groups on them, variations of maybe different molecules involved to make them have sort of different properties. Soy wax as opposed to beeswax, as opposed to paraffin wax, but they all are basically the same thing.
Got it. I think one of the reasons I remember sending that question to you was just I remember thinking it's pretty unique how it can become liquid and then go back to being a solid, and seem to do that so many times,
But butter is kind of that same way.
That's true. I guess I never really reused butter. So that's why, like with a candle,
Yeah,
it's done it so many times by the time the candle's spent that it seems more unique, but hopefully you're not doing that with your butter and for no reason just heating it up and melting it and then letting it solidify again and over and over and over.
And it does kind of change because it has so many different things in there that the consistency of it changes once it melts and solids back.
Right.
Melts and solidifies back again.
Right.
Okay, so now that we know what waxes are, we can more easily talk about how candles work.
Okay, sweet.
So one thing about candles that blows my mind is how does that little wick burn forever?
Yeah.
If you just had a string that what you lit on fire, it would burn and be gone.
Yeah.
And something has to be happening to the wax because candles get lower.
Mm-hmm. Yes, that is one of the things I remember asking, like, I think my mom one time as a kid when I lived at home still, maybe like middle school, was like, where does all that wax go?
Well, I'm going to tell you. The answer is so sciencey and so cool.
Okay, sweet.
So for all of you who've ever wondered about this, if you haven't wondered, pause, take a second to think about what could possibly be happening.
Yeah.
And now I'm going to tell you. When you light the wick, it gives off enough heat for two things to happen.
Okay.
One, the solid wax melts.
Mm-hmm.
And that is chemistry right there. You've put enough heat in that the molecules are moving around enough that they've separated from one another. Their intermolecular forces are overcome by the energy put in. We talked about intermolecular forces a lot. Basically, the molecules want to hang out together, but the more energy you put in, the more they're going to be moving around and they're able to not be as close to each other.
Right.
Okay. And then that liquid wax through capillary action, probably. It could also be through, I think it's called adsorption, where it sticks to the wick through some intermolecular forces and, you know, the way liquid does.
Yeah.
The liquid wax is drawn up into the wick. The same way if you put a paper towel into some water and you'll see the water crawl up the paper towel.
Oh, wow. Yeah.
So the liquid wax goes up into the wick, and then the liquid wax is so hot from being right next to that fire that it reaches its boiling point. The molecules are moving even more, so much that they become gas.
Wow. Okay.
So that's the first thing that happens. The solid wax goes from a solid to a liquid. The liquid is drawn up closer to the point of the fire, and then it turns to a gas.
Got it. And that at the same time would be preventing the wick from just completely burning up because of there being something else to burn or something? I
think the wick is burnt, but I think that wax in there is, yes, something else to burn. So that's the second thing that happens.
Okay.
The second thing that happens is a combustion reaction. And we talked about that in the episode about what is fire. But basically the carbons and the hydrogens in the wax vapor, the gas, it has to be the gaseous form of wax.
Okay.
That reacts with the oxygen in the air. So you have carbons and hydrogens from the wax gas with O2 in the air. And then those two things don't just react. They need energy to form the reaction.
Okay.
So you got to put a little energy in.
Right.
The heat from lighting the candle is enough energy for the wax vapor to react with the oxygen in the air and have a combustion reaction.
Okay.
And the combustion reaction creates CO2, water. The molecules rearrange. You had the carbons, the hydrogens, and the oxygen, and they just rearrange to make carbon bonded with oxygen, hydrogen bonded with oxygen, H2O, CO2.
Got it.
But the other byproduct of that reaction is energy in the form of heat and light.
Right.
So you put a little bit of heat in to start the reaction. And then once the reaction is going, it gives off so much heat and light that it basically just keeps feeding itself.
Right. There's a huge source of new things to fuel that.
Yes.
Right below.
Yes.
it makes up the entire candle.
Yes. So it's just this snowball of a reaction where, say you have a little bit of wax that melts, goes up into the wick, becomes gas, does a combustion reaction. That combustion reaction gives off the energy that fuels another amount of wax melting, going up into the wick, turning into vapor. You have enough energy for it to do a combustion reaction. It gives off even more energy.
Yeah.
And that fuels more wax melting. So it's just a repeated reaction that happens over and over and over again.
Yeah. Interesting.
So literally the thing burning in a candle is wax vapor. It's not the liquid wax.
Yeah.
It's not the rope.
Mm-hmm.
It is the gas form of the wax reacting with oxygen to give off heat and light.
Man, that's crazy.
And because of that, because there's that wax vapor is right there at the candle wick, that's going to be the hottest point of the flame.
Right.
Because there's so much of the fuel right there in the middle.
Yeah.
And because it's not the liquid wax that's reacting, it's not as if that whole candle is going to catch on fire.
Yeah.
Unless there's a bunch of gas floating around right over it.
Right.
So when you blow out a candle, that little trail that comes up of smoke is actually
wax vapor.
So the combustion reaction travels down the wax vapor back to the wick where there's a higher concentration of wax vapor.
Nice. So it's like this little leftover aspect of the reaction still happening for a little while.
Yep.
Even though we already have extinguished the main heat source and stuff like that.
Yeah.
If we do it at the right time, we can take advantage of that and get the reaction all going again, the circle of life going again.
And you can visually see just wax vapor and gas don't react with each other. Wax vapor and the oxygen in the air don't make a reaction.
Right.
You have to light that wax vapor. You have to give that energy for the combustion reaction to start over again.
Right. Dang, dude, that's crazy.
It's so sciencey.
Yeah, and more complicated than I thought. I did think wax would be more complicated, but the whole candle burning stuff, I didn't really think was that complicated. I don't know.
Yeah.
Like I remember whenever I asked my mom that question forever ago, she just said like, "Oh, it burns it up." Like it made it seem like, "Oh, okay, I guess I should have thought that." And just I didn't really expect there to be this many steps to it and how important it would be to the whole process.
I had never thought about what makes a candle burn.
Yeah.
Until I was trying to put together an episode on wax.
Yeah.
And then I was just amazed. I'm amazed. And it's so sciencey. There's so many different science concepts. Mm-hmm. There's the different states of matter, solid, liquid, gas. All of them are present, which is kind of cool.
Yeah.
There's a combustion reaction. There's products of the reaction or heat and light. And then it's just sustaining itself.
Yeah. Wow.
It's amazing.
I also remember thinking just the functional part of my brain. I often thought like, okay, first, obviously candles, we love them now because they smell good.
Yeah.
The vibes of their light are nice too, but the smell, I think, is the main reason we have them. Of course, back a long time ago, it was because of the light that people had them.
Yeah.
So I thought the wax was just there to slow down everything.
Me too.
So that it would not burn up so fast. It's like put something in the way of this wick being burnt up so that this little flame will stay around for a while so that I can write my memoirs or poetry or whatever people did back in the day. But constitutions, etc.
More than that.
Yeah. Wow. Very interesting.
Very interesting. I'm very amazed.
I guess that could have been part of why they did it in the first place, but way more was going on than they knew.
Yeah.
You know, but man, dude, that's cool.
That is cool. I don't know how people figured out to do this, and I'm really amazed at the science behind it.
Yeah. Yeah.
Do you want to take a stab at telling that back to me?
Yes, I would love to. Okay, so here's what's kind of coming to mind for me. And I think it's because I've got batteries on the mind because we talked about them last week.
Oh, yeah.
So the way that I started thinking about this was similar to that, where it's like we've got with a candle, all these things are primed and ready. Mm-hmm. All they need is something to start it. It's almost like we have a perfect circle of kind of a chain reaction kind of thing that'll keeping itself going.
Right.
Except we're missing one link of that chain. or in the case of like a battery, it's like it needs to be connected to itself in order for that to happen, and it's like just missing everything else, you know?
Yeah.
In this case, we're missing just one little piece,
Yep.
but the most important piece. So when we light the candle, the wick starts to burn, which causes the wax to first melt. And the wax is made of carbon and hydrogen.
Yep.
Right? And that like...
Maybe a few other things, but mostly carbon and hydrogen.
Right. And for the reaction, those are the main things that we talked about. And first it turns into a liquid, and then it's drawn up into the wick.
Yep.
In, what was the word you used? Capillary action?
Capillary action is when there's a small space and water climbs the walls of a small tube, or I think technically, I should have looked this up, but I didn't, so don't hold me to it.
Okay.
There's a word like adsorption or adhesion, something like that, that means a molecule clinging to the walls of something else. And that's kind of what causes the capillary action.
Got it.
I think.
So it's drawn up to the heat, to the hottest part.
Yes.
And when it gets there, it turns from a liquid into a gas because of the heat. It boils.
Molecules are moving around, wiggling around so much that they get further and further apart.
Right. So we've got already at that point, had all three states of matter.
Yep.
It went from solid to liquid to gas.
Yep.
And then as it turns into that wax vapor with the heat right there, it is able to react with the oxygen in the air and combust and turn into something totally different, where the carbon and hydrogen react with the oxygen to then instead have CO2 and H2O as the, would you say, byproducts of that? What do you call that?
Yeah, byproducts. Or just the products of the reaction.
Products.
Yeah.
But they combust, which keeps the reaction going because it is heat and allows that flame to just keep being almost like relit over and over and over, right?
Right. And when we are teaching students this concept, we put heat as a product or a reactant. So you need energy to start the reaction. So in the form of heat is what we do. So there's like a little bit of heat on this side.
Yeah.
Plus the carbons and hydrogens and the oxygen. And then we put an arrow to say like that makes water, CO2, heat, and light. And you have the students draw the heat and the light in as part of a byproduct of the reaction.
Right. And it's also the beginning of the next.
Yep. Because you have some heat and light.
Yeah.
To fuel. I guess you don't need light to fuel, but heat to fuel the next.
Yes. Yeah. So it's the beginning of one thing and the end of another.
Yep. So that'd be a fun way to draw this. This is not chemically proper, but if you did heat, the wax molecule, the oxygen, and then an arrow, and then you did heat, CO2, water, plus wax molecule, oxygen, and another arrow.
And if you just did it in a circle to where heat is the last one, but also the first one.
Yes.
Then that'd be kind of cool.
That would be pretty cool. That would be really cool. Yeah.
So I was kind of imagining like a circle.
Yeah.
In my head, and just like a piece missing, which is the heat.
Yeah.
So, is that right? Did I miss anything?
I think that was perfect.
Dude, that's interesting.
That is so interesting. I was amazed. So very cool. Also, it occurred to me, and I wish we had thought about this for Monday's episode when we recorded that. That experiment, is a more advanced experiment. But if you want to just talk to kids about it, you can have a candle and put it under a jar to a clear jar or something that will keep the oxygen out, and they can see the flame extinguish. And that's a great conversation starter with your kids about flame as well. And where does the flame go? What do you think is happening? That kind of thing.
I remember being shown that as a kid at some point by a teacher or somebody, and just being like, whoa, like I didn't really think about the fact that something could be extinguished without touching it or like blowing on it.
Yeah.
And just like starving it of oxygen was something that was totally new for me. And I remember thinking that seemed really magical.
It is pretty magical. Yeah, I didn't even think about doing that. Maybe we'll do a separate chemistry at home episode on that.
Yeah.
On down the line.
Sweet.
So that's it. That's how candles work. I'm amazed by that. I think it's so fun and cool. But
Me
also,
too.
is there something so fun and cool from your week this week that you want to tell me about?
Sure, I'd love to. So this is one that I thought about a few days ago that is not a huge deal, okay?
Okay.
But I think that you and many of our listeners will be able to relate to this feeling that I had, that even though it's a podcast that I've listened to that probably most people haven't, the feeling that I had, I think, is one that you guys will be able to appreciate. Are you ready?
I'm ready.
Are you curious? Are you like, what the heck is he going to say?
I have no idea what you're going to say.
So one of my favorite podcasts, which is not actually a podcast, it's an internet radio show, but which we don't have to get into, called Time Crisis.
Okay.
It's hosted by Ezra Koenig, the lead singer and songwriter of Vampire Weekend,
Okay.
and his friend Jake Longstreth, who's a painter.
Okay.
And it's been like one of my favorite shows to listen to for the past couple of years.
Okay.
But I got into it when they'd already had tons of episodes done.
Yes.
You know that feeling when
Yes.
you're like, okay, I love this. There's so much
And it
here.
will never run out.
It'll never run out. I, after trying for maybe like 2.5 years, finally caught up
Oh my gosh.
on, maybe I didn't say the name of it. Time Crisis is what it's called.
You said it, I think.
Okay.
Yeah.
So I finally caught up on Time Crisis. And this is actually a couple weeks ago that I did that, but I realized how nice of a feeling it was and how I have to share that.
That feeling always makes me sad.
So I didn't feel sad. I mean, I felt a little, but I did feel like what's nice is that now when the new episode comes out, I'm more excited.
That's true. That's true.
And it's very current. And I'm like, oh, I'm hearing about what they're talking about right now. What's
now,
happening in
yeah.
their lives, or like the commentary that they are having about something happening in the world. I'm up to date on it.
I think then I just feel a little empty. Like, now what am I going to listen to?
Mm-hmm. Yeah,
I don't have my go-to.
Yeah, it took me so long to catch up that it did feel like I was never going to.
Yeah.
And I did often feel like, man, I missed that, or like,
Well, congratulations.
yeah. And they do a lot of like referencing things that happen in real life, so that always made me feel like, man, I wish I was listening to this while that thing was happening.
Yeah.
Because I would be kind of laughing with them about whatever. So anyway,
Very cool.
so that's my good thing. So shout out to Time Crisis on Apple Music. Definitely check it out if you like music and people talking about music and people talking about corporate food history.
Corporate food history. Interesting.
Yeah, that's one of their main segments is they kind of do dives into like corporations and food and the weirdness of our culture here in the United States around that stuff. So
I can always get behind people talking about how weird the United States is.
Oh yeah. Yeah. What about you, Melissa?
That was definitely a good one. I think this is a few fun things all rolled into one.
Okay.
My sister lives in another state,
Mm-hmm.
and she happens to be coming into town this weekend.
Do you mean another state of matter?
No, another state in the United States.
Got it. Okay, that makes more sense.
And she happens to be coming into town this weekend,
Uh-huh.
and it's her birthday.
Nice.
And she didn't plan that on purpose. She's in town for an unrelated reason.
Yeah.
But I'm so excited, and I get to actually make my sister a birthday cake, which making birthday baked goods or special event baked goods for people I love is an act of love for me.
Yes.
I love doing it. It's something I want to do. I want them to enjoy really carefully made, full of love things on their birthday and or special event.
Yeah, yeah.
So it's also my brother's birthday. Weirdly, they were born one day apart,
Whoa.
3 years apart. If my brother had been born just a few years later, they would have shared a birthday.
Oh, interesting.
Isn't that crazy?
Yeah.
3 years apart. But so I get to celebrate both of them. I got to make a baked good for both of them. And it required me making caramel sauce for the first time ever.
Okay.
And that went really well and was really fun. And the thing I made was a turtle pie. So inspired by those turtles. They're called turtles. They're caramel pecans with chocolate on them.
Yeah, yeah.
And it was really fun and I really enjoyed it. So I'll send some pictures along of that on Instagram.
Dude, very cool.
I'm so excited about that. I am so excited to celebrate both of my siblings' birthdays together. I'm so excited that I got to bake for them. I'm so excited that I made caramel for the first time. It was just all around a really fun thing.
Yeah, so it sounds like a pretty boring week. Anyway, just kidding. ECU is exciting so many times in a row. It's like, it's so funny because Melissa really does love baking that much. And like,
it's true.
I probably already should share this, but how you called dibs on being able to bake the cake for my son's birthday well before we were even like thinking about that stuff.
Probably late December of last year.
Yeah. Which is so,
he was like 6 months old.
Yeah. Which is just so funny to me because it's like not my thing at all, but you can just tell that Melissa gets like a ton of joy out of doing it. So
I love it. I want people to enjoy it. I like tweaking recipes until they're perfect. It's just really fun.
Yeah. Very cool.
Yeah. Thanks for letting me bake your son's birthday cake. That was the most fun. And also, thanks for coming and learning about candles and being as interested in it as I was. And thanks to all of you listeners for coming each week to learn about chemistry. It really is so fun and so special for us every single week. If I could, I would bake all of you a little baked good to show how much I love and appreciate y'all. But it is not feasible.
Yeah, that's very true, unfortunately. But you can just share the pictures of your baked goods with all of us. Right. That's as close as we can get.
Right.
Well, Melissa, thanks for teaching us. And thanks for being, wanting to bake us all some goods. Listeners, if you guys have any ideas like candles, something very everyday in your life, but that has some really cool chemistry underlying makings and mechanics and stuff like that, please, we'd love to hear your ideas. Reach out to us on Gmail, Instagram, Twitter, Facebook at Chem for Your Life. We are that on all those platforms. We'd love to hear your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. But if you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. References for this episode can be found in our show notes or on our website. Jerem Robinson is our producer, and I'd like to give a special thanks to S. Navarro and In Newell who reviewed this episode.